Hello everyone, and welcome to today's webinar, Top 5 Best Practices for Kubernetes Network Security and Compliance. My name is Michael. I'll be your host. I'm sitting in for Erica today. I am pleased to announce today's speaker, Christopher Lilienstolpe. He is the original architect behind Tigera's Project Calico. He speaks at nearly over 60 meetups yearly, educating on networking and network security for modern applications and microservices. He also consults with Tigera's enterprise clients on security and compliance for their modern applications. So, before I hand the microphone over to Christopher, I have a few housekeeping items that I'd like to cover about this presentation and the webinar platform that you're on. First, today's webinar will be available on demand immediately after the live session and will be accessible through the same link that you are using now and on the Tigera BrightTalk channel. We've also added some attachments and links which are available in the Attachments tab on your screen. There you can find a copy of today's deck and some other related links. And also, if you have questions, we'd love to hear from you. You can ask those questions by going to the Questions tab on the right and asking them. We will get to those questions at the end of the presentation. And if we don't get to your question, we'll make sure to do our best to answer it and follow up afterwards. So, without any further ado, I'd like to hand the mic over to Christopher and to our presentation today.
Thank you, Michael. So welcome, everyone. What I'm going to be talking about today is some of the approaches that you should be thinking about for securing your Kubernetes environments and maintaining compliance in your Kubernetes environments. I'm going to talk about 5 best practices. And these are, what I'm going to be really talking about is what you need to be thinking about in these areas. And I'll give you some examples of what we've seen other customers do, what types of technologies you might want to look at for doing these things. But I'm not going to be prescriptive in this. And I welcome questions. We can dive into any of these if there's interest. So first, let's talk about why this is different. And I've talked about this a lot before, but why do we need to talk about this now in a Kubernetes or containerized world? Why can't we use exactly the same mechanics that we've used before? And really, the thing is that application development and deployment has fundamentally changed, or is in the process of going through a fundamental change, and it's happening much faster, I think, than most people realize. And we're taking applications, first of all, and we're decomposing them into microservices. Instead of rewriting the same code 20 different times in 20 different applications in your stack, you decompose things into services so that you have a microservice that does one thing. It can be consumed by other microservices, and you start sticking those together like Lego blocks to build your applications. That is a pattern that's being actively pursued today, and part of the reason for doing that is it makes your application development deployment much more agile, faster response to changing market requirements or customer requirements, etc. So the microservicization or creating microservices instead of monolithic applications is one driver. In order to have those microservices be consumable wherever you want to deploy them, we're wrapping those in containers, Docker containers, Rocket. There's other container mechanisms out there, but we're containerizing these microservices, and those become the deployment artifacts. We'll talk about deployment artifacts in a bit. As you do this, you really want to have these environments be automatically respond to failing workloads, to increases or decreases in demand, etc. So if you want to have a responsive environment, you need to have automatic orchestration, and that's where things like Kubernetes, etc. come in, where you basically explain to Kubernetes how you want your application to behave and how it's made up, how it's composed, what microservices are involved, etc. And then Kubernetes, or one of the other orchestration platforms out there, Kubernetes seems to be the dominant one today, will then deploy those applications and manage the life cycle of your application stacks for you. And we'll do that in very fast time cycles of milliseconds. It will make decisions, and it will manage potentially very large fleets of microservices, of containers, hundreds of thousands of containers across thousands of servers is sort of the scope where some people are already. And you want to be able to deploy these things wherever it makes sense. So let's say you start off with a private data center, and then you decide you want to extend into a public cloud for whatever reasons, cost control or agility. It takes time to build a data center. Their data centers are in existence and from various providers like Amazon, Azure, Google, etc. So you want to deploy there. Or maybe you want to deploy into an area where you don't have organic footprint. Let's say you're a US-based SaaS provider and you want to test the waters in Europe instead of building, or in Asia, instead of building a data center there, you might want to go try and deploy in a public cloud first and see if that will work. Similarly, acquisitions, M&A functions, the other, opposite of acquisition, you get spun off. You need to have flexibility because the thing you're acquiring, for example, might be running in Azure and you're running in AWS. So you need to be able to place these workloads where they make sense, and you need to make sure that your artifacts and your policies and everything else are portable across all those platforms, all those environments, rather than having to rework everything because you move from, say, AWS to Azure or Google. So that's how some things are changing in this space. If we go to the next slide, so we have this new environment. However, it does bring with it some consequences. Any change brings consequences. So first, from a security standpoint, perimeter security is no longer adequate. We have to assume that part of my network or infrastructure is compromised. There are two types of organizations in this world: those that know they have an advanced persistent threat internal to their organization, and those that don't. So we have to assume there's compromise. Part of that can be just because we're deploying so many different artifacts, so many different microservices today that have variable provenance, where the developer got the base code from, etc. You might have imported code that might have a problem. You might have gotten spearphished and some developer doesn't even know that he's inserting bad code somewhere. So we have to assume that there's compromise in the infrastructure. You also can no longer use security policies that are hard-coded based on locations, a zone-based environment. You're in this VLAN, you're on this IP address, this application is on this IP address, because in a Kubernetes environment or Kubernetes-like environment, those things change. There aren't things like separate VLANs. There aren't things like static IPs. You can do that, but you sort of break the model. And what do you do if Kubernetes decides it needs to auto-scale a given microservice from 5 nodes to 100 nodes? It's got to get those addresses from somewhere. So having security tied to hard-coded location-based assets is really no longer appropriate. Secondly, or thirdly, constant need to reconfigure firewalls. Most folks today, if you do a firewall change, I'm going to say average we see is a couple of weeks for someone to get a firewall rule change put in. I've seen some folks that go up to 4 months. Some folks will take it down to days. None of those is the 5 or 10 minute time frame with which a developer can push a new version of the application to meet a blue-green test or something along those lines. So if I need to update a firewall and it takes 2 weeks, then it doesn't matter if my developer can use Kubernetes and Docker to deploy a new version of the application in 5 minutes if it's going to take 2 weeks to get the firewall updated to allow that to function. So we're sort of missing the boat and the benefit of doing this kind of approach if we're still stuck with legacy static firewall rules. Similarly, in this kind of environment, next vein, visibility and traceability. In this kind of environment, most of the traffic now that used to be internal to a monolithic application is now traveling across the network, doing something we call east-west traffic. These are microservices making calls to other microservices. So we now have most of the traffic in your network is going to be what intra-application, but inter-microservice traffic or east-west traffic. And visibility mechanisms, et cetera, that we have that were primarily focused on ingress and egress out of a cluster aren't really fit for purpose when we're talking about flows potentially between hundreds of thousands of endpoints. Similarly, because the artifacts that those visibility systems used, like IP addresses, are now dynamic, you might end up with a log that says IP address A talked to IP address B 3 months ago, and the auditors might be interested in that conversation, but you have no idea what that thing was 3 months ago, because that IP address might have been reused multiple times in the same day. So that log is pretty much useless. And it's like an IP address talked to another IP address on a port, but I don't know what the source was and I don't know what the destination was. So there's a visibility problem there. You also need to aggregate this data. There's a lot more data. There's a much richer set of signals coming out, but you do need to aggregate it to get into your CM. And it's got to be correlated. Again, go back to IP addresses of the CM, and that is keying off of IP addresses for that aggregation. That's not going to work, because that same IP address could be used by multiple different microservices in any given day or even in any given hour. And workload identity. It all comes back to this workload identity. I need to know what the actual workload was, not where it was in the network at a given point in time. Lastly, controls and compliance. Security teams in this environment are unable to provide complete and accurate data, and again, this comes back to visibility and traceability, in order to make sure that you are compliant, in order to ensure compliance and prove out to a compliance audit that you've been compliant. Most of the compliance tools and reports have been built around the fact that these applications were static, the VMs were static, they lived for months or years, or the servers, etc. And that's no longer the case. The last thing, and probably the most important thing about this change, is today most organizations are very siloed. The network teams, the security teams, the platform teams, the application development teams are all very siloed. And the way they interact with each other is in a waterfall model. They pass tickets back and forth to request services, request changes. That doesn't work in this kind of model where you're trying to be agile and develop things. So you need to start having security tools that allow these groups to all collaborate in an agile fashion, rather than relying on trouble tickets and email to make your changes. So those are some of the things that change in this environment, and some of the things you need to be thinking about as you move to this kind of environment. So I've sort of identified 5 things that you really should be thinking about as you go onto this journey. So why don't we start with the first? And I'm going to talk about controls and compliance. The first thing we probably should do is make sure that you're deploying what you think you should be deploying. So you will probably want to use artifact analysis, static and or runtime analysis, to increase confidence that the workload that you're deploying, the microservice or the Docker container that you're deploying, is not compromised or isn't vulnerable, doesn't already have 20 CVEs on it. So that's one thing. Is this thing that I'm going to deploy trustworthy? There are a number of repos, repositories for containers that you can use. Some of them come with platforms like OpenShift. Others you can use publicly, like Docker Hub or Key, and those can do container scanning for you, continual container scanning, so you know that at least the thing you're deploying doesn't have any known CVEs, or at least no major CVEs. Or even if it has a major CVE, you can look at it and say, that's not something that's exposed in this container, so it's not a critical thing for me to cover. But at least you go into this with your eyes open. So let's take a look at those workloads. Second, you need to maintain a provenance. Within this one, go back. Michael's a little fast on the button there. Maintain a provenance that is verifiable and traceable on your artifacts. So once you've written that code and you've checked that code and you know it does what you want it to do, you want to make sure that that is always the same, that somebody can't come in later and make a change to that code and not have you know about it. Because what's going to happen when Kubernetes decides it needs to spin up 10 more of these things, it's just going to go back to the same repo and pull that image again. So unless you know that that hasn't been dorked with or screwed with, you don't really know if you're deploying the same thing. So you want to use source code control systems like Git or something along those lines. You want to maybe do fingerprinting on those workloads. You want to do things to make sure that once you've decided through your CI/CD pipeline, et cetera, that this workload is the thing you want to deploy. This version of the container is what you want to deploy. You want to make sure that's what you always deploy. So let's make use of those source code control systems and those CI/CD chains, fingerprinting and other things to make sure that you're deploying what you think you're deploying. And in order to do that, let's make sure that these are repeatable, again, using your source code control system in a CI/CD chain. Instead of having people just use, say, kube control to deploy a pod when they need to, maybe that should go through a CI/CD chain such that when somebody commits the code, it goes into the CI environment and then CD and deploys. And that way everything's traceable back through that source code control CI/CD system. It's all appropriately logged, etc. If we go on to best practice 2, now we need to make sure that all our deployments are in compliance. One of the things you want to do, because things like IP addresses are ephemeral, we need to use other things to identify the workloads. That could be fingerprints. That could be metadata, labels on the workload. This thing is a PCI contaminated database. This thing is a PCI compliant querier of that database. This thing is, for application, is a microservice in application Bob. It is in stage prod. It's been approved for use in production versus dev or test. So all those metadata labels are actively used by other things in Kubernetes. Your developers are attaching these labels. If you can use these labels as an identity rather than an IP address, you're way far ahead, because the labels now describe what the thing is. Same as fingerprints, etc. So you can then start attaching compliance regimes via labels. This workload requires to be in the PCI compliance regime or the GDPR compliance regime or ISO or whatever ones you have, FedRAMP. So use this metadata to identify the compliance regimes, the functions, the state, etc. That is a much more useful and if you think about multi-factor way of identifying a workload than just an IP address. Second, you need to make sure that your compliance policies are themselves controlled and automatically applied. So instead of making the decision that I need to apply these policies, do I need to apply this policy to this workload, etc. Instead, you should be saying, here is a label that identifies a state or a function of this application. This database is contaminated with PCI data, with credit card data. That might be the label, PCI contaminated. Then you can write policies to say, I don't care if it's a database, if it's an application, if it's an S3 bucket, if it's labeled that is PCI contaminated, then the PCI set of policies must be applied to it, or the GDPR policies must be applied to it if it's PII contaminated data and location is in Europe, or anywhere else, frankly, with the way the rule's written. But the policies are attracted to the state in the workload automatically, especially if you're using something like Kubernetes Network Policy and Tigera's solution that implements that, rather than you having to make a decision on a case-by-case basis, or worse yet, having your developers have to make that decision if something needs to be secured or not. And you need to make sure that for the policies that do things like enforce compliance and keep you out of a congressional testimony room, that only people who are appropriately qualified can make changes to those policies, i.e., the developer can't change what the PCI control policy is, only the compliance team can, etc. So those are, you need to make sure that the policies can only be changed by the appropriate people or created or deleted, and that the policies are automatically attracted. So that's the next thing you need to do to ensure that your deployments are in compliance. If we go to the next slide, we need to make sure that logs are meaningful and durable. So we're talking about potentially thousands of servers. We have customers who are using Tigera solution with tens of thousands of servers. So you've got lots of endpoints all reporting, and some of those servers might be hosting hundreds of workloads each. So you've got to keep all of this correlated so that all of the signal coming in to the logging platform, to your CM, etc., is correlated so you can actually detect what's really happening in the platform. So all these events, both administrative and operational, must be logged. And by administrative, I'm talking more about audit laws, rules, who deployed that container, or who launched that deployment, who edited that policy, etc. And operational. This policy blocked traffic to this PCI workload because the other end was not PCI compliant. So those are operational logs versus the first, which are administrative. All of these things must be date-time correlated. You need to make sure everything has the same concept of time so that you don't have things firing off logs that look like they're minutes apart when really they happened at the same time, or worse yet, look like they happened at the same time when they really didn't. They need to be immutable. Your logs need to be immutable. If somebody can go in and change your logs aren't really all that useful. So you need to make sure that you have some form of immutability control, be it write-only access for the system, controlled write-only, and then other people can have read, or fingerprinting of the logs. There's multiple ways you can do this, but you do need to make sure they're immutable. Those logs need to reference long-lived identity, and preferably multiple-factor identity. What were the labels? What were the Kubernetes namespace? What was the Kubernetes namespace this was deployed in? What was the actual name of the pod, which is derived from the actual deployment name? What was the service account, i.e. the X509 certificate that was attached to this? So you need to start looking at multiple forms of identity to be able to, with surety, say this workload was exactly of this type that generated this logging event. The other thing that's really useful is to refer to the policies or controls that were involved in the event. So let's say we say that traffic was blocked or allowed to this PCI contaminated database. Not only do I want to know that that was allowed or denied and who actually made that access, what was the other end, but it'd be really nice to know what policy allowed it or denied it so I can see if my policy controls were correct. It might have gotten blocked, but if I go back later and say, well, it was blocked by some other policy, not the PCI control policy that it should have been blocked by. Now I know I have a policy problem. The flow is still blocked, so we're still okay, but we're okay by accident, not by purpose. So having the actual policies that were involved allow you to then say, go back to your auditors and say at any point in time, at 4:58, 3 months ago on a Friday afternoon, the PCI policy was working exactly as expected. Or it wasn't, and we found out why, and we fixed the problem. The other thing you need to do is have alerting and diagnostics based on time series data streams. There's a lot of signal going on here. You probably do not want to have your alerting system triggered for each and every dropped packet, or you will never get any sleep, and it will eventually just become background noise. No one will respond to it. So you're really interested in alerting and logging and reporting on data based on time series. Did a cluster of events happen right next to each other or over a long period of time? What was the rate of events for this policy? And below this level, it's just standard door knocking and I don't care versus, oh, that's a really interesting thing. All of a sudden I went to 10 times greater violations on my PCI compliance policies than I had before. When we might be having an event going on. It's really useful then to say, oh, and it's this version of this workload that did that, and I trace that back, going back to my earlier comments, and see that was based on this version that just got pushed, and we pulled the developer who did it pulled a new version of something out of Docker Hub or Key, and it turns out that maybe that thing isn't quite Jake, isn't quite good. So that tells you immediately where your problem is. If we go to the fourth item, we need to embrace zero trust network security. And this is going to sound like a broken record because everyone talks about zero trust security. But what we mean by this is we have to assume that you have one or more compromises in your network. I used to be a U.S. park ranger, and one of the things we got in our officer survival training was once you find a weapon on a subject, don't stop searching because people who have one weapon probably have more than one weapon. So just because you find a compromise in your infrastructure, don't assume you found all the compromises in your infrastructure. Always assume there's compromise. Always assume there are multiple compromises. There are multiple compromises. Having the assumption that a single control point can provide security is a pretty bad idea, because that might be the thing that's compromised. So that calls us to another point, which is multiple control points. You want to make sure that your policies, the controls that you're putting into your system, are enforced at multiple points in the infrastructure, say in the pod, outside of the pod, on the same host, in the infrastructure, etc., that you're providing multiple control points such that a compromise of any one of them does not compromise your security posture. Multi-factor identity. You want to make your decisions based not just on a single thing, but on multiple factors. What's the behavior of the application? Is this pod behaving like we expect it to do? It's trying to talk to the things we expect it to talk to. Is it, the identities that the orchestrator has assigned to it? Cryptographic identities based on service accounts or something like that. So you want to make these decisions about what to enforce on what based on multiple factors of identity. So again, if there's a single compromise, you're still probably safe. And you want to do these controls at multiple layers of the stack because there's different data at different points of the stack. So I could write a policy that Bobs can talk to Alice's on port 443. That's great. That's at the network layer. I could make it stronger by saying Bobs can talk to Alice's on 443, but they can only make an HTTP GET for customer records. The URI is prefaced by customer record. Now I've got a layer 5 through 7 behavior attached to this as well. Lastly, I can say Bobs can only talk to Alice's on 443, can only do HTTP GETs to URIs prefaced by customer record, and require a certificate, i.e. a service account that belongs to this group of service accounts. So I now have controls at the TLS layer, at the application layer, i.e. that HTTP query, and at the network layer. And now all those things have to line up in order for that traffic to flow. If any one of those things doesn't match, the traffic is blocked and I get an alert. So having controls at multiple points, at multiple layers of the infrastructure based on multiple identities, I now have a reasonable assurance against compromise, unless the compromise happens to be on the wire and I've got a man in the middle. I've decided to allow the traffic, but then there's a man in the middle. We've talked about cryptographic controls. In this kind of environment, it is best to encrypt the traffic in flight, and you want that to be automated. You don't want to have to be managing two things. You don't want to be managing the keys yourself. You want the system to do that because, again, these pods are coming and going all the time. You want a certificate assigned to each individual workload because you don't want a certificate compromise to take out 100 or 200 or 1,000 or 10,000 workloads. Lastly, you probably don't want your developers to be doing all the TLS work themselves. Developers screw up crypto. Not only that, if you've had all of your developers build the crypto into your app and then Heartbleed 2 comes along, you have to figure out all the applications, all the microservices that use TLS, which should be all of them, and go fix all of them with the new library, versus having a service that maybe embeds in the pod, like Istio and its Envoy proxy, to actually offload that TLS within the pod, but outside of the application. So you now have one place to fix it if there's a cryptographic problem. And that's a key thing here, is most people will either embed crypto in the application, which means you have to touch all the applications when Heartbleed happens again, and it will, or you have some big middle box somewhere, or even on the host. Say we do it at the host layer. You've got 100 containers. That means 100 containers on that host all have to share their keys with that one endpoint. Becomes a juicier target. There's 100 keys to compromise if I get on that host. If I do it as a middle box, TLS gateway, maybe I have tens of thousands of keys that have to sit on there. It's created a wonderful man-in-the-middle point for an attacker to go after and get all your keys to the kingdom, literally. If you do this where it is something that slides into the pod but is not part of the application itself, it only has one key. It only has the key for that instance of that microservice. The compromise is limited. The blast radius is limited. So look at doing something like Istio Envoy to do your TLS security rather than either doing this as a middle box approach at the host level or higher up the stack. Lastly, orchestrate your security just like you orchestrate your code. So security should not be something that you deal with on an entirely separate pane of glass. You might have a pane of glass that gives you security type information, but you want to make sure that your security system can be integrated into the CI/CD pipeline, the source code controlled, etc., so that at any point in time you can roll back to a known good security standpoint. If somebody writes security rules and they touch a sensitive area, make sure that those are RBAC controlled. Only the compliance folks can write rules that are about compliance. Make sure that changes that people make potentially have code review, as in policy review, or policy enforcement review. All those things that you already do for your code deployment, you should be doing for security. Once you've put these security artifacts into your control system and you're using CI/CD to deploy them, then the orchestrator needs to deliver these. The orchestrator is orchestrating everything else in the system. Using a security enforcement mechanism, policy enforcement mechanism, compliance mechanism that is not driven by the orchestrator is frankly barking mad. I tend not to be so vocal sometimes, but your orchestrator is orchestrating everything else. It's orchestrating your storage. It's orchestrating your connectivity between your microservices. It's doing all of those things. If your security is separate from that, then you will inherently have a disconnect, an impedance mismatch between your security platform and everything else. So anything you're doing should be driven via the orchestration, either taking input from the orchestration, events from the orchestrator so it can respond, but you want the orchestrator and your platform to be very closely linked. If they're not, you're going to open up holes, seams, and they will be exploited. So make sure that your compliance and security platform are integrated with the orchestration. The orchestration system can drive it just like it's driving everything else. Your controls, your security artifacts need to be workload-centric. You shouldn't be thinking about this VLAN can talk to this VLAN. VLANs are ephemeral. They may not even exist. IP addresses, etc. I'm sounding like a broken record here, but the security needs to be tied to the artifacts the orchestrator and other things surface, and it needs to be enforced as close to that workload as possible. It needs to be tied to the workload, not to a secondary thing like the IP address of a workload and do that in a middle box firewall somewhere. The security enforcement needs to be very closely coupled to that workload. So wherever that workload goes, the policy follows, the policy enforcement follows. So I think with that, those are what I'd call 5 best practices. There are probably a few more that are, well, there's definitely a few more that are out there, but 5 was a good starting point. Love to hear what your thoughts are about or questions you have at this point. So, Michael, I turn it back over to you.
Thank you. Once again, if you have questions, you can go ahead and put them into the input on the right that says questions. So we do have some questions. A couple questions that are around when you mentioned CI/CD systems. And so I guess maybe can you talk a little bit more about security when integrating a CI/CD system into Kubernetes?
Sure. So there's two factors to that. One is the security of the link between the CI/CD system and Kubernetes, and 2, what you might want to do from a security control standpoint for things going through a CI/CD system. So first of all, Kubernetes, most of the damage you can do in Kubernetes is controlled by RBAC. So if you're doing CI/CD to say CD specifically to deploy deployments or services, etc., into Kubernetes, you need to make sure that that CI/CD system has the appropriate RBAC controls, is using TLS and using client-side search to authenticate, etc. as well. But you want to make sure that the CD system is appropriately scoped. And you might even want to think about having different CD runners based on what the thing is you're deploying. You might have a different CD runner, for example, for things that are going to deploy compliance tier policies versus developer policies versus deploying just having a developer or DevOps deploying an application. Those all might be different CD runners with different RBAC controls on them, different RBAC principles on them to make sure that somebody can't subvert one of the CD runners to do something that they shouldn't be able to do. That's one. If we look at the other side of that equation, and we look at what controls can you put in CI/CD to make sure that you're maintaining security in your platform. Things that are security relevant, like label assertion and other things, can be done in CI/CD. You can basically say in your CD system, anyone who tries to assert a label of PCI compliance true, unless that person is of the right group and get, which is again should be tied back to RBAC, that says they're part of the compliance team, then instead of just running that CI/CD pipeline, that should then get called out for a code review, for lack of a better word, just like any other code review, and that code review goes to someone on the compliance team to make a decision. Should that workload be labeled PCI compliant as true or not? So there's using CI/CD to enforce controls on what goes through the CI/CD pipeline, as well as controls of the CI/CD pipeline itself to make sure that, again, limited, least privilege. Make sure that the runners, etc., have only the privileges necessary to do the things that you're asking them to do, which means having different runners for different types of tasks that you might run through your CI/CD pipeline.
We had a question just come in, actually, that said, so with Zero Trust Network, does that mean that perimeter firewalls and DMZs and so forth, are they dead, or do you no longer need them?
I have two answers here. So I will first take the inflammatory answer and say, if you do it right, I would say that is probably not the case, so long as you really do it right. So for example, you may not need them if all your workloads have been appropriately hardened and you're using TLS and you're doing appropriate authentication for every TLS flow, etc., then you may not indeed need a firewall or a DMZ. And if you are interested in that, you can go back and look at the Google Beyond Corp papers for their thinking on that, and I tend to agree with that. In fact, I use a similar thing. I wrote a blog about this a couple weeks ago. There's a follow-up blog coming out, what I did to protect Tigera at Black Hat. And we were very much based on application layer encryption rather than classic firewalling. That said, classic firewalls and DMZs do have their place, and especially if you can move them off-site. So I start looking at perimeter. What I might be asking the perimeter to do then is bulk filtering out DDoS attacks, filtering out things that just are corrupt coming in that I'd otherwise be expending CPU cycles on my worker nodes to filter, when really it's just simple static rules that keep the bulk of the noise out. No one should be SSHing into my cluster from the outside, so I can just filter that at the edge, and it's a very clean point. I have to make the assumption that somebody's going to get past that, so I should have rules that block SSH internally as well, but at least it's a first level coarse filter. If you can move it off-site, then things like DDoS damage doesn't come in through your constrained WAN links and is blocked at the other edge where it's up to the service provider to absorb rather than you. So I think there is a place for them, but do I think you could have just as a secure environment without them? I think it's possible, but you have to do it. You have to put a lot of careful thought before you go down that path.
We had a question around non-production environments and what approaches you would have to balancing security when you're using a non-production environment also in that.
So I think the production non-prod environment thing, you can relax your security requirements on non-prod. You probably should make sure that non-prod can't talk to prod. Or you might want to say that non-prod or test can read from prod but not write to prod, right? If you want to test on real data. So all those rules are possible. The thing, though, that I like to say, and this goes back to a large electric car manufacturer who had a bit of a problem on their Kubernetes cluster some time ago, be very careful having different policies for prod and non-prod, or test and dev versus prod. Because if you test with one set of security controls, and then you go into production with a different set, there's a couple of problems. Best case, you end up breaking things because you can't get access to things that you tested and you got access to in test because you had weaker security controls. That means the system's protecting you. The other option, of course, is you didn't test the control that you're putting in, and it turns out the extra control you put in prod, doesn't work as you intended. Your test didn't catch that because you're only deploying that in prod, therefore prod becomes your test, and you may or may not discover that control doesn't work. Also, if you test with one set of controls and you plan to go prod with the other, just like every other deployment, those decisions get made at the last second. You know, cutting down the wire, you got to go prod tomorrow, and then you discover when you go into prod it doesn't work. So what are you going to do? If you're under pressure, you're going to deploy with the thing you tested, not what your target was prod. So if you don't test with what you're going to deploy, you're going to deploy what you tested. So I would caution strongly against having different security models for test and dev versus prod. You want to make sure at the get-go, as part of your integration testing, your functional testing, your end-to-end testing, is testing like you would go into prod, because otherwise you will go into prod with what you tested with, and that is probably a bad idea.
The question came in that mentioned around all the different compliance requirements that you had talked about. And so when you're having to address multiple compliance needs, what's the best approach for that?
So I think the best approach, and what we counsel folks and what I've seen folks do, is you should not be writing policies for individual workloads. You should be writing policies for behaviors or personalities, if you want to think of it. You know, is this thing PCI contaminated? Does it have customer card record data in it? And it's PCI contaminated. Does it have personal identifying information in it? Well, if it's got PCI data in it, it's probably also got personal identifying information in it, so it's also PII contaminated. You know, it might have PII data in it and have health records, so it's HIPAA contaminated. Instead of trying to handle all of those possible matrix of possibilities, you should just have a PCI policy. Only things that are identified as being PCI compliant can talk to PCI contaminated resources. Only things that have been proven as HIPAA compliant can talk to HIPAA compliant contaminated resources. Same thing, GDPR compliant to talk to PII contaminated resources. Then you identify that resource as being PII contaminated and PCI contaminated, or PII contaminated and GDPR contaminated, or HIPAA contaminated. The policies will be attracted to that label, that metadata that says this thing is PII contaminated or PCI contaminated. That way you don't have to do the full set of matrices of what the possible combinations are. You just say, here's my PII rules, here's my PCI rules, here's my HIPAA rules, and those deploy independently to each of those workloads. And it might mean that the next version of that database, you split the patient record from the PII data. Now, the patient records have some anonymizing data because you're going to be doing some research on them. And there's some PII data that maps that anonymizing record locator to the patient identifying information. Then the resource that had been PII contaminated and HIPAA contaminated is now just HIPAA contaminated or PII contaminated. And the next version will apply the right policies to each of those two new workloads, whereas before it was a single workload that had both. The compliance team never had to change anything there. All that changed was the labels associated with it that said, what is the personality of this workload, or the set of personalities? I think that's one way of doing it. We did get one question about, sounds like you're saying that the logs should be able to answer all questions that may occur on all activities at any time. Are there any good industry tools, papers, books, etc. that would help us ensure that we're covering those bases? I'm not really sure about papers and tools, papers and books. You should be logging everything if you can. You might want to be aggregating those logs, etc. But yes, it's better to have more logs, provided that you can make sense of them, than less logs, and saying, gee, I really wish I knew what happened at that moment before it all went horribly, horribly wrong. So, yes, everything should be logged. There are some great tools out there, things like EFK stacks, which is Elasticsearch, FluentD, and Kibana, or Elk stacks, which is Elasticsearch, Logstash, and Kibana. You can look those up. We have lots of customers that use EFK or Elk, and then the logs go into that, and then you can start doing Google-like searches. Show me all the events for over the last 30 days where pods of this type tried to talk to pods of this type, and was the traffic allowed or denied. So there's lots of tooling around that you can do, and there's commercial offerings that sort of package those up nicely as well. Those are the tools. As far as books and papers, there's been a lot of stuff written over the years about managing logs. I can't think of anything off the top of my head that I'd say would be a good starting point, however.
Okay, well, great. That's all the time we have for questions today. We'd like to thank you guys all for attending. Give everyone give Christopher a big virtual applause. Two messages for you guys before we go. We are hiring here at Tigera. It's a great, dynamic, fun place to work. So if you guys match any of these open positions or are a talented person looking for a great career, please do contact us. And lastly, the next upcoming webinar that we have is on September 12th. It is 10 a.m. Pacific, 1 p.m. ET. It is on IDS and IPS in the age of TLS v3. Now, those are some acronyms, so this will be a technical presentation rather than a best practice, and there's the link to go get it, okay? So without further ado, I'd like to thank you guys all for coming. The copy of the video of this webcast as video will be available as soon as it processes on BrightTalk, usually within 5 minutes, and it'll be available if you want to review. So thanks again for coming.
Thank you.